Okay, now we're going to convert from rectangular equations to polar equations. So kind of the same sort of thing. We're going to use the exact same relationships. X is r cosine theta, y is r sine theta. And we remember the reason that's true is because we know cosine is x over r and sine is y over r. So how do we convert from an equation like x equals -3? Now I do want to remind you that x equals -3 in the rectangular coordinate system, you go to -3 and you draw a vertical line. So this graph is a vertical line. So what would that look like as a polar equation? All you have to do, again, take out the x and replace it with r cosine theta. So we now have r times the cosine of theta is equal to -3. And then we're simply going to solve it for r. So r would be -3 divided by the cosine of theta. And we know that the reciprocal of cosine, we can bring that cosine to the top by doing -3 times the secant of theta. So -3 secant of theta, which is actually similar to one of our graphs from a couple of lessons ago, would be, again, that vertical line. Y equals x root 3 over 3. Now, let's talk about what this graph would look like. This looks a little bit different from what we used to seeing. Let's write it as root 3 over 3x. That's what normally or how this equation would be written, to where this is in slope-intercept. This would be slope, and this would be your x, and then your y-intercept would be 0. So this is going to be a linear equation. So all we're going to have to do, again, is take out y, replace it with r sine theta, take out x, replace it with r cosine theta. So we're going to have r sine theta is equal to r cosine theta root 3 over 3. That's all I did was replace the x and y. And I'm showing you that you could go ahead and manipulate it from there. You can move the 3 over, get your r's on the same side and all that. However, there's an easier way to work these. So just showing you that's one way of doing it. Well, let's look at it this way. Let's move the 3 over first. Let's leave it as simple as we can before we start working. So let's do 3y equals x root 3. Let's move my x over here with my y and move my 3 over here with my root 3. So that would give me y over x is equal to root 3 over 3. Now, why would I want to do that? Now, I want to remind you y over x. Now, that looks familiar. If you remember that, again, sine was x over r, or excuse me, sine was y over r, cosine was x over r, tangent was y over x. So what you can actually do is replace y over x with tan theta is equal to root 3 over 3. Now, had we kept that like I had it before, let me clean that up, which I do want to remind you, tangent is slope. So notice what it says here. The slope is root 3 over 3. Again, the slope before in this equation is root 3 over 3. But anyway, if had you left that the way that it was before, let me rewrite that again. You could have achieved the exact same thing. If you'd move this over to the left, you'd have r times sine theta over r times cosine theta. And move this over here with the root 3, you would have got root 3 over 3. The r's would have canceled. Sine over cosine is equal to tangent. You would have got the exact same answer. Number 3, y equals x squared. We're again simply replacing the y with r sine theta. We're going to replace the x squared or the x with r cosine theta, and I'm going to go ahead and square it as I do that. So that's a theta instead of an x. So there's my equation now. I can move my r over by dividing by r, just so that one of these will cancel. And I've got r by itself now, and then I'm going to move this cosine squared over here. Now let's clean that up some. We have r equals sine over cosine squared. I'm going to split that because I know that sine over cosine is equal to something else. And then I'm going to split that into sine over cosine times 1 over cosine. Again, because you see the cosine squared on bottom. I know the reason I did that, I know that sine over cosine is tangent. And I know that 1 over cosine is secant. So this equation would be, which by the way, notice it's a parabola. This parabola could be graphed in polar coordinates or polar system by doing r equals tan times secant. And just because I find it interesting, I've done that on Desmos. Here's a graph of r equals tan times secant. And notice that you get the exact same y equals x squared parabola. Number 4, same thing. You have an x equals y squared over 5. That's also going to be a parabola. It's going to be cupped to the right side because of it being a y squared instead of x squared. So let's replace the x with r times cosine theta. And let's replace the y with r times sine theta. And I'm just going to put the 1/5 out front. We're squaring the r's, or squaring the r sine theta, so it's going to be r squared times sine squared. Kind of the rest of it's going to be very similar. Let's move the r over by dividing by r. And when you divide, and you can show the whole thing divided by r, but since it's all one term, you can just divide this one piece by r, and that's going to cancel. Let's go ahead, since I've got r by itself here, I'm going to move my 5 this way by multiplying, so I now have 5 cosine theta equals r sine squared theta. And we can go ahead and move our sine squared theta over here. Gets rid of that. So I now have r equals 5 times, now I'm going to split this again. I'll split it as cosine over sine, and then times 1 over sine, just to where it looks a little bit cleaner. I mean, this is a right answer, but I just want to clean it up and write it as nice and neat as possible. You have the 5, which is actually a transformation. One of your transformations. Cosine over sine would be a cotangent of theta, and then 1 over sine would be a cosecant theta. So you have 5 times cotangent cosecant would be a sideways parabola. Number 5. I like this one. X squared plus y squared equals 16. Now, don't forget about all of your different transformations. Or not transformations, excuse me, all your different ways to convert from polar to rectangular and vice versa. The best one to use here is I know that x squared plus y squared is actually equal to r squared. That's one of those transformations to where you can transform from one to the other. The other ones that we can use again is theta was inverse tangent of y over x. We could have used that, or just y over x equals tan theta, which is actually what we used up here. Y over x was equal to tan theta. We can use x equals r cosine theta, y equals r sine theta. So any of those 4 are useful. So here, x squared plus y squared is equal to r squared. So r squared is 16. So the equation of this, take the square root, you can do either r is 4, or if you did r equals -4, you actually get the exact same graph. So we know this is a circle. X squared plus y squared equals r squared in a rectangular coordinate system is a circle. This is the radius squared. So to graph that in polar, it's very simple. R equals 4. Or r equals -4 would give you the exact same circle. Here, it looks like a circle again, but actually it's not. When you move that y squared over, you get x squared minus y squared equals 1. If you remember correctly, this is what's called a hyperbola. So what we're going to have to do is somehow replace these. And I believe the only method we have here is taking out the x and replacing it with r cosine theta. And I'm going to go ahead and square it as I plug it in. Minus, take out the y and replace it with r sine theta. And go ahead and square it as you plug it in. And that is equal to 1. And from here on out, I mean, it's just simplifying. To get the r by itself, let's first factor it out. I have cosine squared theta minus sine squared theta. Now that was very close to being sine squared plus cosine squared, which is equal to 1. Had this been a plus sign, again, we'd have had a circle because it would have r equals some value, because this would be r squared times 1. However, cosine squared minus sine squared is not equal to 1, but it is equal to something. Let me open up our trig identities and I'll remind you. Okay, here, that is going to be our replacement. Cosine squared minus sine squared is actually the cosine of 2 theta. So to clean this up a little bit, we can actually take all of this out and replace it with cosine of 2 theta. So we now have r squared times the cosine of 2 theta equals 1. To get r by itself, let's divide by that cosine of 2 theta. So r squared would be 1 over the cosine 2 theta. Now 1 over cosine, that's also another identity. 1 divided by cosine is the secant of that angle, so the same angle, 2 theta. Now to get rid of that squared, we're going to do r is equal to, and you can do plus or minus. It should give you the exact same thing. the square root of the secant of 2 theta. And there you go. Now, I looked at the answers. They actually left it like this to where you didn't have plus or minuses, so either one of those answers would be fine. Number 7. Now, this is also a circle. However, this circle has been transformed. It's been moved left 1 unit. Has a center at -1, 0. So let's see how that changes our polar graph. So let's see what kind of transformation this would look like when we're dealing with a polar form. Now, to change this, we are going to have to FOIL this out. To square a binomial, you square the first, multiply the two terms and double it, and then square the second. So this is what you now have. We know that x is equal to r cosine theta. So let's replace all of our x's with r cosine theta. You now have r squared times cosine squared theta plus 2 r cosine theta plus 1 plus, we know that y is r sine theta. So you have r squared sine squared theta is equal to 1. Now, the first thing that jumps out to me is, and I know this is a circle, so I know this is about to happen, is these two terms right here. I have a cosine squared plus a sine squared stuff. So what I'm going to do is I'm going to go ahead and group those two terms. I'm going to write it as r squared cosine squared plus r squared sine squared. And I can go ahead and leave this other one over, this plus 2r cosine theta, if I'd like to. And something else, I'm going to go ahead and do this. So plus 1 and this 1 over here will cancel each other out, and I'm not going to be left with anything. So right here, though, is the key. I'm going to group those two terms together, and I'm going to factor out that r squared just to show you what's about to happen. You're left with cosine squared plus sine squared. And this is always going to happen when you have a circle. And if you'd like to, you can go ahead and move that other term to the other side. So equals -2r cosine theta, just to clean up a little bit. Because what's about to happen is all of this right here, cosine squared plus sine squared, is going to equal 1. So it goes away. So you're left with r squared equals -2r cosine theta. When you divide by this r to the other side, because all of this is being multiplied, it cancels with one of these r's and leaves you with r equals -2 cosine theta. So that should be a circle that has been shifted left 1 unit. Okay, number 8. Number 8 is very similar to the previous problem. We're going to start out, however, this one's shifted right 2 and down 1. Let's see what this looks like as a transformation. We might take a look at the graph of it. So step number 1, we do have to square each of these binomials out. So x squared minus 4x plus 4 plus y squared plus 2y plus 1 is equal to 5. And oddly enough, when you do that, this plus 4 and plus 1, when you move it to the other side, cancels with this 5 and it's equal to 0. So they made this nice and neat for you now. And you can erase those if you would like to, just to make it look better. So there's your equation now. Let's replace all the x's with r cosine theta. So I have r squared cosine squared theta minus 4 r cosine theta. Plus, replace all the y's with r sine theta. So you have r squared sine squared theta. And plus 2r sine theta. That's equal to 0. Same thing we did on the last one. The r squared stuff, when you move it over, and you know this is going to be a circle, and this is going to happen. When you group those together, r squared times cosine squared theta plus r squared times sine squared theta. And I'm going to go ahead and move everything else to the other side. So that's going to equal, this becomes a positive 4r cosine theta, and this would become a negative 2r sine theta. Factor out the r squared, you're left with cosine squared plus sine squared, which we already know what it's equal to, is equal to, and I'm going to go ahead, you can, well, I believe I'm going to wait. So let's just copy this down. 4r cosine theta minus 2r sine theta. I don't want us to get bogged down with too much at once. All of this is equal to 1. So you have r squared times 1, which pretty much you can mark out. So you now have r squared equals. Now I'm about to try to get rid of one of these r's just to make it look cleaner. So I noticed that on the other side, both of these terms contain an r. So what you can do is factor that r out, and you're going to be left with 4 cosine theta minus 2 sine theta. And when I divide by this r, it's going to cancel because these are being multiplied. When I divide, it will cancel one of these, and it gives me a final answer of r equals 4 cosine theta minus 2 sine theta. Okay, next section. What about converting from polar to rectangular? Like r equals 7, we know that's a polar graph. Well, we can use these same transformations or same equations to transform these. We know what r is equal to, we know what y is equal to, we know that r squared is x squared plus y squared, we know that tangent is y over x, so let's use those exact same things to transform these. Okay, the first one, r equals 7. What I would do on this one is I would square both sides. Because if r is 7, then I know that r squared would be 49. And the reason I did that, because then I can replace it straight with this. R squared is x squared plus y squared. So there is your rectangular equation. And we already knew that was a circle. If they give you a radius and they say graph r equals 7, the radius is 7, that's a circle of radius 7. This is also a circle of radius 7. Theta is 2 pi over 3. Okay, we know that if theta is 2 pi over 3, our angle, it gives us an angle. Well, we need it to somehow fit one of these, and the only ones that have those angles are here, here, and here. I'm actually going to use this third one. I'm going to try to make it look like this before I can transform it. So what I'm going to do is if the theta is 2 pi over 3, then the tan of theta will be the tan of 2 pi over 3. What I just did was actually took the tangent of both sides, which is perfectly legal as long as you do it to both. So I now have the tangent of theta is equal to the tan of 2 pi over 3. Now 2 pi over 3, that's 180 divided by 3 times 2, that is 120 degrees. And you can do this, you can actually work that out. The tan of 120 is going to be root 3, and we're nearly done. The last step, or one of the last steps here, is I know tan of theta, to convert that into y's and x's, I know tan of theta is y over x, and that's equal to root 3. So the last thing to make it look like what we're used to is let's move the x over, and y will equal x root 3. That is actually a line. It's in y equals mx plus b form. This would be your slope because it's root 3x. You can flip-flop those two values because multiplication is commutative. It would have a y-intercept of 0, but that would be the slope, which again we know that slope and tangent is the exact same thing. Number 11. R equals the 3 over the secant of theta. So let's go back, and here again is all the things that we can use. Now we don't have anything to do with secants, however, we do have cosine stuff. And I know that cosines and secants are reciprocals, so we might have to change that to some cosine stuff. So let's see what we can do here. R equals, if you were to write this and bring the secant to the bottom, that'd be 3 over the cosine. Okay, and now it's pretty easy. Let's take the bottom and move it over here by multiplying, and you have r times cosine is equal to 3. And if you remember, r times cosine is equal to x. So x equals 3. So try to make it fit one of your formulas, one of those 4 formulas that they gave us, and then manipulate it from there. This one's going to be done the exact same way. R is equal to negative 2 over, when you bring the cosecant to the bottom, it becomes a sine. So therefore, multiply both sides by sine, you get r times sine theta is negative 2. R sine of theta is equal to y. Y equals negative 2. This would be a horizontal line if you graphed it. I didn't tell you, but this last one would have been a vertical line had you graphed it. Number 13. Okay, what you can't do here is if you were to move that sine over, you would think you'd get an r sine or r cosine, but actually you don't. So a trick that sometimes really comes in handy, and it is in this case a lot, it's going to make things a whole lot easier, is I know what r squared is. I do have a conversion for r squared. I have a conversion for r sine, r cosine, r squared, and y over x or inverse tan. However, nothing for r. So let's go ahead and do this. Let's multiply both sides by r. Let's turn that into an r squared. And it actually does us a favor on the other side too, because it turns it into r times sine of theta. Now it can be very easily changed. R squared is equal to x squared plus y squared. R sine theta is equal to, y, not x. So there's what we now have. Now that is a correct answer, but I don't want to leave it in that form. This looks a lot like some problems that we've worked in some earlier chapters. Let's do this. Let's take all of our y stuff and let's move it to the same side. 2y becomes minus 2y. Leave yourself a space, and that's equal to 0. Now what you have is x squared stuff, y squared stuff equals, this will eventually be r squared stuff. This is going to be a circle. However, to get it in the form that you're used to seeing it in, let's complete our square. You have x squared stuff, y squared stuff. Well, this y squared stuff, let's make it look like what you're used to. So take this whole term, or these set of terms, complete the square. Take half of this, square it, and you get 1. Add that to both sides. So now you get x squared plus, when you factor this, then it looks a whole lot better. Adds, multiplies would be a y minus 1 and a y minus 1. That is a complete square now. 0 and 1 on the other side is 1. That is a circle that has a radius of 1 that has been shifted to that's been shifted up 1 unit. Next, r equals negative 6 cosine theta. And the exact same strategy. Multiply both sides by r, and you get r squared equals negative 6r cosine theta. R squared can be replaced with x squared plus y squared. R cosine theta can be replaced with x. And do the exact same thing. You have x squared, move the 6x over by doing plus 6x, leave a space. We're about to complete the square. Y squared, that's already completed. There's no other y stuff, and that's equal to 0. To complete the square, you're going to take half of this number, multiply it times itself, and you're going to add that to both sides. Now let's factor. This is a perfect square that's going to factor into x plus 3 times itself, plus y squared is equal to 9. You now have a circle that's been shifted to the left 3. So the center of that circle would be negative 3, 0. The radius of this circle would be 3. That is your final answer.